test. Okay.
Okay, thank you very much for the audience waiting. And we're all set, and we're going to introduce Renaldi, who's going to bring us the combination of Python and the Internet of Things today. Renaldi is founder and CEO of Dress System Studio. Oh, sorry about that. And I think he brought up some very fascinating gadgets here today, right? So let's welcome Renaldi for his talk.
Thank you, everyone, and good morning. Firstly, I'd like to applaud all of you for choosing to tackle such a difficult topic on such a bright and sunny morning. IoT is no easy topic for one to get used to, so thank you for that. It's quite a feat to be able to really understand IoT and all the concept that it has, and furthermore, to implement it in a language that not many people have done so on it already, Python. So, without further ado, we will begin. Firstly, a bit about myself. As introduced, I am the CEO and founder of Gray Studio, a company that manufactures IoT-based devices for the use of being able to further people's acknowledgement about IoT and to be able to implement it into useful uses. Aside from that, I've been a Python coder for more than 5 years. We've done a lot of Python in Gray Studio, so we do use it in a lot of our implementations, and that's where I got a lot of my experience from, first-hand experience in coding in Python. I am an occasional contributor to the Python community because I usually contribute mostly to being able to move my company forward with my coding. I am an IoT enthusiast. I like piano, programming in different languages, watching comedy and action movies, marathons, and commenting about food because I am actually some kind of a food critic actually. So you can ask me about food as well, aside from us asking about Python. And what I dislike, I only dislike one thing mostly is autocorrect on phones. I mean, who has done something like this before? But people have probably already got this on Siri or something, right? When you write down something and you accidentally autocorrect to something weirder. And after the conference, you can reach me on Instagram, as you can see there, or you can reach me on email. And this is important if you want to ask me further questions that you may not ask RD at the conference at the end of this show. So you may ask me at those emails as well if you want to know more about what I do or be able to know more about the stuff that I talk about today and about how I implement it, because I'm not going to be covering everything, but I'm going to be talking about the essential parts of Python and how IoT can be implemented mostly. So, here is Kevin Ashton's definition of IoT. Kevin Ashton was the founder, the person who coined the term IoT. And we can see over here, he said, in the 20th century, computers were brains without senses. They only knew what we were told them, but we don't want a definition like that, right? On this bright morning, we want something clean, something to grasp onto, so not some one paragraph like that. So let me give you the summed up definition. It is the internetworking of physical objects embedded with electronics, softwares, sensors, actuators, and network connectivity, which enables these objects to collect and exchange data. So that's a definition for people who do not know IoT, basically in a nutshell. So that's one definition that you can use and that you can hold on to. That way, you're able to tell what's IoT to people that way and really grasp into the concept of it. So, 4 pillars of connectivity and IoT. Hence, the concept of smart. You've may heard a lot of people say smart when you come to IoT. First pillar, SCADA. Supervisory control and data acquisition. So, this is autonomous systems that are able to collect data from around you, which are then passed on to the central system, which then passes the data onto controllers so that we're able to control different systems. In other words, it is what we call the internet of controllers in this sense. RFID. using radio waves emitted from electronic tags to be able to transfer the data into central systems, which is then processed through a reader to be able to then convert the data for us to be able to track devices and know their location. WSN, these are spatially autonomous networks that are able to transfer onto a central system that are able to then be processed, and through there you're able to get the data from the environment or the physical environment, such as pollution data, monitoring data, and those are some types of data that I will talk about today in the implementation part. Machine to machine. This is a crucial part of IoT because it is what we call the Internet of Objects or devices, because we're able to transmit data from there, from our devices, for example, from your car, and there's a part of your car which is able to transfer to our central system that something is wrong with that part of the car. So that way, we're able to fix the problem before it goes even worse. So this is a crucial part of IoT that many people have to understand as well. A typical architecture of an IoT sensor network. So as you can see over here, this is one of those such networks. You can see as such, and this is very important to understand because we will be going over such an architecture in our implementation. So you are able to see that we have the data center there, which receives the transmit data from the internet, which originates from, as you can see below there, those devices. There are many devices that have IoT objects these days. Even if you don't realize it, we have fridges now, we have our mobile phones, our cameras, our thermometers, and you can see all those being transferred into a hub where the data is collected and it is put on an access point, which is then transferred into the internet, which ends up in the data center, and it shifts back and forth to be able to retrieve the data, and it goes that way until the data can be used readily for public purposes. Where does Python fit into the picture of IoT now? We've been talking a lot about IoT, but we haven't really gone to Python. So maybe some of you have not really heard Python being used in IoT. Well, today you will. So it is actually a big thing actually to really go into the IoT definition of Python. So there's a lot of things that it can be used for, which I'll talk about. But it is a crucial language within the IoT concept to really understand. So we will be looking at 3 devices: the Arduino, the Raspberry Pi, and the Intel Edison. Wrong picture of the Raspberry there. I mean this Raspberry, not the Pi. Now let's do a bit of comparison between the Raspberry Pi and the Arduino, shall we? I'll be actually focusing on the Raspberry for this implementation process for Python because, as many of you may know, Arduino uses C and C++ and not Python, and only Raspberry uses Python. So since this conference theme is PyCon after all, we will focus on Python, which is got through the Raspberry. And if some of you haven't seen the Raspberry, you may see it here. As you can see over here, this is a Raspberry module. I did not bring an Arduino because I thought we should just focus on the Python process, but you can see the Arduino over there. So firstly, there are more processes at one time for Raspberry. So Raspberry can do many things at one time versus the Arduino only able to do one process at one time. So this is one consideration when people start to think about the usage of what you want to do. If you just want your device to conduct one process, then you should just use the Arduino. But if you want your device to act as, for example, like a control hub for something, you should use the Raspberry because that can conduct many more processes at one time. So you should consider when using this when you want to choose between using both of these. Now, this is one topic which I've heard a lot in my conversations with people and in forums. Like some people also told me, why do you still use the Arduino? Raspberry Pi is more professional, and that's what a lot of people think. However, I say it depends actually, because like I said, it depends on the use. Some people think Arduino is only for people who still haven't experienced programming before. After all, the founder of Arduino from MIT originally intended it to be for people who had not experienced programming and wanted to experience it before they entered MIT. But like I said, every tool has its usage, and finding the right usage for it and the right time to use it is the correct steps to take for this. So you can't really say it's more professional, but again, it depends on the use. And Raspberry Pi can be used on Linux only. As you know, we have the Raspbian on the Raspberry Pi versus Arduino that can be used on almost any platform from Mac, Windows, Linux. So that's one advantage that the Arduino has over Raspberry. And of course, there's the direct use of Python on the Raspberry Pi, as mentioned before, versus the not so direct use of it on the Arduino. Now, let's get a bit more into theory before we really get into the implementation. There are two main uses of Python as the language. And firstly, it's the interaction with the MCU with the IoT concept. And as you can see there, secondly, it is the programming the functions of the microcontroller itself. So now I'll talk about the programming of the functions of the MCU first. Firstly, we can give values to the sensors that way. Now, this is just one case study because I'm going to be focusing on being able to interpret sensors using the Raspberry Pi using Python. So with Python, you can actually start to really program the functions of what it is going to do. And you can do that through directly the DOS prompt, as you have already know if you have already used Raspberry Pi before. There's also the setting of the main protocols. So you're able to do this via Python through the DOS prompt as well, which I will also talk about during the implementation phase of my presentation. And we'll be focusing on Amazon Web Services, as you may have already read in the briefing of my talk. And also, possibly, Python-based microcontrollers. There are some microcontrollers that are only based in Python, so you may also look for that when you are going to look for microcontrollers to program in. So that's one thing you can keep in mind as well. Now, the interacting with the MCU with the IoT concept. So this is brings us to the second phase. After you have programmed your microcontroller within Raspberry Pi or say another microcontroller, you're able to establish connections with the cloud per se. For example, in Amazon Web Services is one example, or Bluemix, or Google Free Always, if you have already heard of that. So these are three different cloud-based services that you can actually send your data to, and these cannot be accomplished without being able to program in Python with the cloud. So, as I said, linked to the API, we're able to program that. When they generate an API key for us, we put it in, bam, into the DOS prompt, and we connect the device into the cloud, and that way the device can be recognized through the API being used. And I'll talk more about that during the implementation phase. And of course, the communication protocols. When we start to talk about TCP/IP or Bluetooth or near field communications, this all comes into play. So this has to be taken into consideration as well. We can program which type of communication protocol do you want to use. And for Amazon Web Services, I'll be talking about using MQTT as a communication protocol. So that's also one thing to look forward to. Here's an example of a server-wise interaction architecture. As you can see over here, we have the device. You can press the device there, which sends it eventually to the Raspberry Pi itself, which lights up something, which transfers the data over using the Internet of Things concept. And this is a sample from IBM Bluemix, as you can see here. We are using the IBM Bluemix platform, which eventually it's transmitted and it's interpreted in runtime using the Pi runtime language. So you can see over there, which is transmitted into better data. And we may have third parties which help us to interpret the data, such as you can see there, Twilio, which we can also program to alert us via text message, as you can see over there. So this basic example of how devices communicate with the cloud in a nutshell. So you can get the main idea from here. This will be an important part of implementing the IoT concept within the Amazon Web Service architecture. So you can also take note of this. Firstly, we can see that the device transmits a message over to the server, as you can see there. Now, Amazon Web Services is actually a complex platform for many starters, so I won't really get much deep into that yet, but I'll go on the main points in my presentation. So, firstly, we have the authentication phase. This is actually a very long process of authentication that they have to go through. It requires a lot of certificates, keys, encryption keys that you have to put in the device, as well as the Amazon Web Services itself, and it requires certificates as well. So regarding the whole process of authenticating with Amazon Web Services, I'll not be going into this presentation, but if you do want to ask me after the conference through my email or through my Instagram, you're welcome to do so, or you can catch me after this conference, or you can also ask me some other time as well, because that's a really long process which took me actually quite a while as well to actually master in the end, and it requires a lot of practice. And of course, after the authentication, we have the gateway, which then transmits into the rules engine. So you have to also have this thing called rules to be able to implement into your device, which is transmitted between the device as well as the Amazon Web Services, and which eventually reaches the Amazon Web Services through a message, which they do eventually through also encryption key as well, which eventually also leads to the registry being put on, as you can see there. So it's a kind of a complex process, so I'll just jump into the implementation so that you can get a good idea. Now, I originally intended to actually put up the Raspberry Pi interface on and bring up the DOS prompt through VNC to be able to do a virtual computer, but eventually, unfortunately, I ran into some problems, so I'll just show the results on the IoT network directly. Okay, so as I was saying, we can see the results of the transferring of the DH222. So the DH222 is actually a module for temperature and humidity. So as you can see over here, we can see the data being extrapolated. So over there, you can see that there are some dots which marks the time, as you can see over here. There was actually a long line because I turned it off for a while and eventually turned it on again. So from this model, you can see that this is the DHT22 module, and you basically have to connect it to your Raspberry Pi in order to generate the data. And after that, there are a lot of it's easy to implement because there are a lot of DHT22 libraries that you can use on the internet. And eventually, when you do use the DHT22 module on the internet, you can just rearrange the time intervals of how you can actually put on like the time limit between the time of taking one data with another. So if you want 5-minute intervals, you can put it on 5 minutes, but if you want 1-minute intervals, you can also put it to 1 minute. So it's really simple, and you can see the effectiveness of this. You're able to put in all the data, as you can see here. And I'm going to show you also an alternative of one of my previous projects as well. So this was actually one of the industrial projects I've been through. This is more larger scale, but this is based on Arduino. And as you can see over here, there's much more data, and it's based on different sensors. We have PM1, PM2.5, PM10, CO2, pressure, temperature, humidity. So you can see all of this being implemented through being able to program in Python that way. And for the Arduino, of course, being able to program in C or C++. So you can see that this way, you're able to transmit data in a much more fashioned way, as you may say it, because you don't have to wait in one location always for it to gather data, but you can just transfer it through you to be able to see the data directly. And moving on to the next one, I'll be talking now about the AWS. Can just move this here. So this is an example of one of my implementations of AWS, and switching to items. You're able to see the data being collected over here. So you can see there is the key, the timestamp, and the payload. So every one of these data consists of different times being collected for it. And as you can see over here, I have already scanned data, so you can see that it's collected within 30-second intervals. As you can see over there, it uploads data every 30 seconds. And you can see that there's the temperature, humidity, and for each of these data, you'll be able to click on them and see each of the details in general. And from here, you can also click the options. So it's a pretty good way to be able to understand how the data is interpreted that way. And from there, you're able to analyze the data better. So again, I do apologize for not being able to show you directly through the DOS prompt of the Raspberry Pi, but eventually you can also experiment on your own as well. So, but again, if you want to ask for more details on how I managed to get the data to the Amazon Web Services, you can ask me also later, since it's actually a very long process. So, moving forward that, now, does PyOT have a bright future? This was what actually came to my attention. One of the PyCon reviewers also brought this to my attention when they said that the last development in PyOT found on the internet was actually 2 years ago, which is actually a long time, since not many people have really played with Python with an IoT. And though some people have developed it for personal purposes, they haven't really been active on the GitHub community or other online communities to be able to put IoT implementations within Python. So, and also, this was actually a quote that I found on the internet, which was actually kind of disturbing. Python has become a valuable resource for web application developers, but some don't see it transitioning to IoT anytime soon, from readwrite.com. So, this is one thing that we have to be aware of when we do go into the Python and IoT sector. So, we should be aware of this. And now, we should talk about the pressing issues PyOT will face. Firstly, security issues. More and more people are being aware of the security issues within Python coding or IoT as a general, because as IoT comes into the surface, there have been many more concerns regarding. I'll just continue without the computer for now. So one of the things that we have to bring up is the security measures within Python. So who here has already heard of the Mirai botnet? No one yet? It's a pretty big attack that happened on databases. So it's one thing that people have to be aware of when they start to go into Python with an IoT. It is a really stressing issue, and one that people should be aware of, because a lot of people were affected at that time, and there has been many repercussions taken. There have been many new security experts that have been consulted for example, the Mirai botnet, and people should be able to optimize their code better and to prevent further bugs from happening like that. So that's one thing why PyOT will become quite a trend within that. And aside from that, there are also industrial issues. Now, one of the biggest markets for IoT is the industrial market because more and more implementations within the industry is already found these days. And you can see that in coal mines, in your car, for example. So those are the issues that people need to take into account when they talk about IoT. So that's another thing to be taken account of. And since the IoT market is growing bigger and bigger, there will be more opportunities for expansion within Python. So from there, people will start to really understand more about how Python can be used to be able to put on a good show for IoT. And from there, people can start developing more and more from how they start from, for example, just a Raspberry Pi from personal uses to actually expanding into more professional uses that way. So that brings me to the end of my presentation. I'd like to thank you. And do we have time for questions?
Yeah. So I think we can take 1 or 2 questions.
Yeah.
You can click the button at your desk or raise your hand. Anyone? Yes, please.
Yes.
Hi, thank you for the talk. My question is, in a IoT environment, if you are using multiple devices, say up to hundreds of Raspberry Pi, and how do you trace if the device is working properly, besides analysis the data from the sensors? Am I make myself clear?
So you're asking like how do we manage to track all these devices to make sure that every one of them is working, right?
Yep, yep.
Yeah. So that's the beauty of the cloud. So basically, the cloud allows you to be alerted to different sensors that you're already using. For example, let's say ThinkSpeak. It actually lets you know if it's functioning or not because you can actually also attach an email function to your coding. So that's one thing that we also did in Gray Studio. We managed to also make devices that alerted people when the sensors came to a high rise or a low rise, or if they are actually stopped working. So when they do stop working, our users are alerted to an email saying, "Oh, device A has stopped, device B has stopped." So from there, people can really get to know whether the devices are still working or not. And to answer your question, that is from the cloud. You're able to monitor all those devices from the cloud and through the text messages that you appear through your programming. And for further information, you can ask with me as well for how to program that sort of thing within the DOS option within the Python for Raspberry Pi. Thank you.
Okay, thank you very much. And if you have further questions, I believe you will have. So maybe we can use the break time, so we can still reach Renaldi for more questions. So let us thank Renaldi for his great talk.